Okay, so there's several methods that we can solve systems of equations. One is by substitution, and one is by elimination, and another is by graphing. So I want to walk you through the substitution method first. It's usually the one that you use the least, to be honest. But remember, you can always check by putting these in slope-intercept form and graphing the lines and checking to see where the lines intersect. So the first thing we're going to do is solve for one of the variables. The idea is that you have an x and a y in each one of these equations, and you want to get rid of one of the variables so you can solve for the other one, and then go back and solve for the one that you got rid of, right? So first thing we're going to do is solve one equation for x or y, substitute the expression into the other equation, and solve for one of the variables. And then once you've solved for that one variable, you can substitute that value into the other equation and get the value for the other variable. So always, I want to emphasize that when you're solving a system of equations, you're solving for the point where the two lines intersect. So you want to make sure that you express it as an ordered pair, okay, which is x comma y. So we're going to go through a couple examples here, and then gradually they'll start off pretty easy, and then we'll get a little bit more complicated, but just about 3 examples for you. Okay, so let's try our first equation. So say y is equal to 4x minus 1, and y is equal to 2x minus 5. Now the first thing I want to emphasize is that if I saw this, I would probably just graph these two lines and see where they intersect. More importantly, I would graph them in my calculator or on Desmos to see where they intersect. So it's much easier to do it that way. But let's say that we didn't have that ability and we didn't have graph paper in front of us. So what are we going to do? Well, both of these equations are solved for y. So in essence, I can actually set these two equations equal to one another and just solve for x that way. So, because they're both equal to y. So I'm going to subtract 2x from each side of the equation, and I get 2x minus 1 is equal to negative 5. I'm going to go ahead and add 1. And I get 2x is equal to negative 4. Then to solve for x, I divide by 2. So x is equal to negative 2. Now I've solved for x, now I need to solve for y. Now I can plug this x value into either one of the equations. I'm just going to use the first one. It doesn't matter. You should get the same value no matter what. So y is going to be equal to 4 times negative 2. Minus 1, so that's negative 8, minus 1, which is negative 9. So my point of intersection should be negative 2, negative 9. All right, so let's try another one where it's not so obvious, okay? So let's have an equation, y is equal to x plus 9. Now keep in mind, your x can be solved for as well. In fact, I'm going to go ahead and just give you a different example. And we'll talk about that one. So let's say x is equal to 4y plus 7. That's much better. So then we have 2x minus 6y equals 12. Now when you have one of your variables solved for in terms of the other, that's a huge hint that probably substitution would be the easiest way to solve for the variable. So what you're going to do is, since I have solved for x, I'm going to plug in this value right here in for x into this equation. So this is what I do. I do 2 times x. Well, I'm not going to use x. I'm going to use 4y plus 7. And then I have minus 6y equals 12. Now what did I do here? I got rid of all my x's so that I'm only solving for y. So I've got 8y plus 14 minus 6y is equal to 12. So now that I have distributed right here, I want two combined like terms. So I have 8y and negative 6y right here. So that's 2y plus 14 is equal to 12. And I'm going to subtract 14 from each side. And I get 2y is equal to negative 2. And I divide by 2 on each side, so y is equal to negative 1. Okay, that's great. I've solved for y. What about x? This is when it becomes great that I can use this equation right here. X is equal to 4y plus 7. So I just substitute it in. 4 times negative 1 plus 7 is equal to 3. So my point of intersection is 3, negative 1. Be sure that you make sure you put your x value first and your y value second. It's very important. Now let's do another one where we don't have a variable solved for and we actually have to do it ourselves. Okay, so let's do one more. So let's do 2x plus y is equal to negative 2 and 5x plus 3y is equal to negative 8. Now, none of these have a variable that's solved for, but if I'm going to solve by elimination or by substitution, I'm going to look for the one that's the easiest to solve for. And that, my friends, is going to be this y right here. Why is that? Because that y has no coefficients in front of them, so I don't have to do any dividing. I just have to add or subtract. So if I were to solve for y here, I'm going to just go ahead and subtract 2x. So now I've solved for y as negative 2x minus 2. All right? I'm going to plug this value in for y into this equation. So I only have x's. So I have 5x plus 3. Make sure you put parentheses around this expression so that you know to distribute equals negative 8. And let's go ahead and distribute right here. So I have 5x minus 6x minus 6 equals negative 8. So this becomes negative 1x minus 6 equals negative 8. Let's go ahead and add 6 to both sides. And I get negative 1x is equal to negative 2. Divide by negative 1. X is equal to a positive 2. Okay. Now I've solved for x, I have to solve for y, and usually I just go back to this equation that I have right here, which is wonderful. So I have y is equal to negative 2 times x, which I figured out was 2, and then I subtract 2. So that's equal to negative 4 minus 2, which is negative 6. So my point of intersection is 2, negative 6.